Welcome to This Explainer. Today we're unpacking what I think is the great paradox of our time, the global green transition. Now, we all know we're pushing away from fossil fuels, right? But what exactly are we replacing them with? And honestly, what is the hidden cost of literally digging all of it up? So is our clean energy actually clean? Think about it. When you plug in an EV or look up at one of those massive wind turbines, you're just seeing the polished end result. You're seeing the finish line of a colossal, literally earth-moving global supply chain. But if we trace those sleek technologies all the way back to their origins, we find a story deeply rooted in the dirt. And it's a story that is way more complicated than just slapping a zero emissions label on something. This whole transition, it runs on critical minerals. We're talking elements like lithium, rare earths, cobalt, nickel, and copper. But here's the absolute scale of the problem. According to both the International Energy Agency and the World Economic Forum, hitting our renewable targets doesn't just need a little more mining, it requires a staggering exponential increase in mining these exact elements. We aren't just talking about a slight bump in production here. These minerals are the undeniable physical bottleneck of our clean tech future. It's demanding resource extraction on a scale humanity has rarely, if ever, seen before. So, here's our roadmap for today. First, the clean energy paradox. Second, the toxic global reality. Third, Indigenous rights in mining. Fourth, rewriting the regulatory rules. And finally, 5, recycling and future tech. Okay, let's jump right into section 1, the clean energy paradox, the reality of renewable origins. Look, to avoid a total climate catastrophe, we absolutely have to decarbonize. No question about it. But here is the catch. Our shift away from fossil fuels has triggered a massive and honestly highly destructive mining boom. We are essentially swapping one extractive industry for another. And the energy-intensive process of actually getting these critical minerals out of the ground, clearing the land, moving millions of tons of earth, processing ore with toxic chemicals, it's actively undermining some of the very emissions we're trying so desperately to save. It really forces us to ask a tough question. Just how much local destruction are we willing to tolerate for global preservation? Moving on to section 2, the toxic global reality, spanning the globe for resources. Because behind all this data, there are real people. Take Huang Shaokong, for example. He's a local farmer living near rare earth mines in China, and he said, farmers like us, we're the vulnerable ones. In regions like Bayan Obo and Guangzhou, which supply the vast majority of the world's rare earths, by the way, local residents are living with severe contamination. We are talking about massive amounts of toxic mining waste, heavy metals, and even radioactive thorium seeping directly into the soil they farm and the water they drink. It is just a staggering human toll for, the magnetic components inside our pristine wind turbines. And this issue, it definitely isn't isolated to China. Down in Chile's Atacama Desert, the process of extracting lithium through mass evaporation has actually dropped local water levels by 30%. 30%! That poses a severe threat to incredibly fragile local ecosystems and iconic flamingo populations. And now, the industry is looking down, way down. The deep sea is essentially the next frontier. Right now, the International Seabed Authority is weighing the mining of polymetallic nodules. Think of these like potato-sized mineral clumps just packed with manganese, cobalt, and nickel, resting right on the ocean floor. Even under U.S. jurisdiction, administrations have explored seabed leases off the coast of American Samoa. But the environmental risks of literally tearing up the ocean floor, we're only just beginning to comprehend them, and the potential disruption to marine life could be absolutely catastrophic. Which brings us to section 3, Indigenous rights in mining, the human cost at home. Consider the remote village of Unalakleet, Alaska. It perfectly represents the kind of sacred historical landscapes that are now facing intense pressure from the critical mineral industry. Because of super antiquated frameworks, like the 1872 General Mining Law, there are virtually zero Indigenous consultation requirements built directly into the claiming of hard rock minerals here in the United States. It basically creates this Wild West scenario where ancestral homelands and deeply significant cultural sites are left incredibly vulnerable to unilateral corporate development. I want you to hear this number: 79%. It is a staggering reality that 79% of all known U.S. lithium deposits sit within 35 miles of Native American reservations. This means the clean energy transition is completely, fundamentally inseparable from Indigenous territories. Let that sink in for a second. Native Americans make up just 1% of the U.S. population, yet they are positioned to bear the overwhelming brunt of the health and environmental risks from this impending domestic mining boom.
It's a geographical reality that absolutely demands a fundamental rethinking of how development happens.
And there is a massive legal canyon between merely having a consultation and actually granting consent. Under current U.S. law, companies and federal agencies usually only have to consult with tribes. That means, they ask for input, they check a procedural box, but it guarantees absolutely zero decision-making power. A mine can legally proceed even if a tribe vehemently objects to it. But on the flip side, true consent, specifically free, prior, and informed consent, or FPIC for short, that gives Indigenous communities the actual authority to approve or reject projects that directly impact their lives and their lands. It's the standard recognized internationally by the UN, but it remains sorely, sorely lacking in our domestic regulatory frameworks. So let's look at Section 4, Rewriting the Regulatory Rules, how the world is responding. Right now, honestly, the global mining industry is just lost in a maze of overlapping, confusing standards. It makes it incredibly difficult to verify who is actually mining responsibly. So to fix this, they're merging 4 major historical benchmarks, including the Copper Mark and ICMM principles, into one giant master rulebook. It's called the Consolidated Mining Standard Initiative, or CMSI. Launching fully in 2026, it's going to force facilities to grade themselves across 24 really rigorous sustainability performance areas. And why does this matter? Well, because by simplifying the rules, you take away the excuses. It forces smaller, historically less compliant producers to finally step up and adopt high-bar environmental and social practices if they want any piece of the global market. Meanwhile, across the Atlantic, the European Union is getting digital to enforce accountability. By 2027, they are mandating what they call a battery passport. Imagine just scanning a QR code on your next electric vehicle and instantly seeing its entire life cycle, like a transparent, immutable record of exactly where the minerals came from, how they were mined, and the exact carbon footprint of the entire manufacturing process. The registry for this system goes live in July 2026, and honestly, it is going to completely change global accountability. It's going to make it so much harder for manufacturers to hide destructive supply chains. Finally, we're at Section 5, Recycling and Future Tech, Innovating a Way Out. Now, there is a genuinely optimistic pathway here. We can actually mine our own trash. The U.S. Government Accountability Office points out that battery recycling technologies, specifically things like using chemical leaching and smelting to recover critical minerals, they are already quite mature. If we manage to really scale them up, we could dramatically reduce our reliance on imported copper, cobalt, lithium, and nickel in literally just 2 to 3 years. But the absurd reality right now, we currently lack the domestic processing capacity to handle it, which means a massive trove of super valuable electronic waste is currently just rotting in our landfills. To build a truly circular economy and finally break this endless extraction cycle, the GAO suggests a 4-part battle plan. First up, establish domestic manufacturing for viable substitutes. Think things like building lithium iron phosphate batteries that completely bypass problematic cobalt and nickel altogether. Second, we have to rapidly build up that domestic recycling infrastructure we so desperately need. Third, actively secure the inputs for that recycling. That means we need aggressive national e-waste collection programs so we just stop throwing gold, lithium, and copper in the garbage. And fourth, pour significant funding into research and development to make these substitutes and recycling methods cheaper and vastly more efficient. So, we've explored how the shift to green energy is currently tied to a massive, complex, and often really damaging extraction of the earth. But between the EU battery passport, unified mining standards, and rapid breakthroughs in circular recycling, a truly clean future is highly possible. So, as we wrap up this explainer, I want to leave you with one last question. What is your role in this life cycle? Seriously, where are your old phones and laptops sitting right now? And how can your everyday choices push us toward a tech future that is actually genuinely clean? Thanks for joining me today. Keep learning, and I'll see you in the next explainer.